boiler really is an evolution and contains some new features, principally the heat exchanger. And what the clever guys have done in our R&D department have managed to squeak a little bit more heat out of every single tube in the boiler. They've changed the design a little bit, made them slightly taller, but because of that they can, as I say, get a little bit more heat from each tube. The original boiler was the Alufer, stainless steel tube with the finned inserts inside, and to a large extent they are still there, but they've been supplemented, as you say, with this additional length of stainless steel tube which has a special dimple in it. And the dimple is there, or the intention of the dimple is to increase the velocity of the flue gases as they pass through the heat exchanger. And speeding up the gas like that gives it it makes it better to exchange its energy with the water that's surrounding the tube, and essentially that's how they're managing to get more energy out per tube over the original. And as I say, that means you can, put fewer tubes in a boiler and still get the same level of output. To 450 kilowatts, you'll get the boiler through a standard door, which obviously means in an older building it's easier for the installer to bring it in and position it. Over and above that, I think it's fair to say that the maximum output of a single boiler, which approaches 1550 kilowatts, is the most compact boiler of that capacity in the marketplace. The new boiler builds on the old tradition of the Hoval UltraGas, in that it's a high water content boiler, and a high water content boiler makes it ideal for a wide delta T. Now, the delta T is the difference between the return temperature coming back into the boiler and the temperature you're aiming the boiler to run at, the flow temperature. So the difference between those two things is what we call the delta T. And traditionally, those delta T's, the difference was only 11 or maybe 20 degrees centigrade, 20K as we boiler techies call it. More recently, the systems are being designed which are designed around a lower temperature return, or return temperature, and that lower return temperature means that you've got a bigger lift in the boiler. And in turn what that means is the greater the lift in the temperature, for the same amount of energy going in, means that you've got to really drop the flow rate through the boiler. And the volume of the boiler, of the UltraGas boiler, makes that, lends itself ideally to that. Like its predecessors, the UltraGas2 has the 2 return connections. So if you happen to have circuits, heating circuits, that are at a very low temperature because they're maybe underflow, or maybe they're running against domestic hot water heat exchangers, where you can now, with the technology that's used there, get returns that are 25-30 degrees C, really good for boiler efficiency. But at the same time, you've also got circuits in the building that are running at more conventional temperatures, perhaps at 80 and 60 degrees C, where the returns are a lot higher. Those can be introduced at different points in the boiler and not mixed, which is the way you would normally see in many plant rooms. And because you do that, you still get that benefit of the cold water at the very bottom of the boiler, which promotes this condensation and maintains the efficiency of the boiler as it's fired.